All right, so now we're going to do some practice on predicting the product in these E2 eliminations. So, like I said earlier, we're probably going to move to a place where we're going to be thinking about substitution and elimination, but at this point I just want you to think about the E2 reactions that could happen with these substrates and what products they could generate. So here's the first three. Go ahead and predict the products, pause the video, do that, and then come back. All right, great job. So how did we do this? Well, it's beta elimination, right? So we have to find the beta positions, and this is alpha to that iodide. This would be beta, this would be beta, and this would be beta. So essentially, hydrogens from any of these positions could be pulled off in those elimination reactions, and that could generate a double bond here. If this one was pulled off, a double bond here. If this one was pulled off, or a double bond here. So the products of this first one could be that, could be that, and it also could be that. So first off, which of these is the major product? All right, more substituted product, more stable product. These are tri-substituted, this is di-substituted, so this would be the minor product. And then what about these major products? Are they the same thing? Are they different things? Yeah, these are the same molecule, right? We would just flip it over to show that these are the same. So really we only need to show one of them. So we'll just cross that one out. And this is the major product. This is the minor product. Same thing for the second one. Maybe if that helped you get started, maybe pause the video now and do the next two. All right, you did that again. So this one, this is a beta position, this is a beta position, this is a beta position. So we'll call this HA. If we pulled off HA, that would make that product. If we pull off HB, that would make that product. If we pull off HC, this is HC, we would make this product. Are any of these identical? Yeah, these are the same thing. So again, we only need one of them, so I'll just cross out one of them. And which is the major product? Yeah, this one is tri-substituted. This is the major product, and this is the minor product. Oof, yeah, that was probably loud. Sorry about that. All right, last one on this last of the three. You've already done this one. I'm going to tell you though, there are three products here, yeah, three products. So if you don't have three options here, come back and do it again. Okay, so the three options are essentially the two hydrogens here are both beta, but it turns out that one of them will make the trans-alkene, and the other one is going to make the cis-alkene, and that's exactly where we're going. That's where we're going next. So this is going to be pretty important. This is going to be kind of the most challenging part of the chapter where we're talking about the stereochemistry of if we took off one with a wedge versus a dash, if this had stereochemistry involved as well. And like I said, that's where we're going next. But those are two options. The third option would be if we took off that hydrogen, that would make that product. The most stable product is this one, so we could say this one's maybe the major product. This is the most minor product, and this is, so if we had to say most, the middle, and the smallest amount, this would be most, middle amount, that's the smallest amount, the most minor product, because it's mono-substituted versus both of those are di-substituted. So we're going to do three more right now. All right, here are the last four predict the products. So hopefully you've already paused the video, done all of them. Here we go. So we have a beta position here and a beta position here. This beta position can do both the cis and the trans. So if we do, we'll call this beta 1. If we deprotonated beta 1, we would form that. And we could also form the cis. But turns out that with these huge terp butyl groups, remember the cis is always less stable, but when we have enormous terp butyl groups like that are going to sterically clash a lot, that actually makes that product not possible. So this is actually only going to form that trans. What about this beta position? Can we do an elimination on that side? So if we try to do that, we would see something like this, right? And what's a problem here? So there's multiple problems, right? We have to think about the mechanism of these reactions. So the OH minus, to form this guy, is pulling off this hydrogen. The electrons are moving there and kicking out that chlorine. So why can't we form this product? Well, if we just look at the product, it's terrible, right? This carbon has 5 bonds. We can't have 5 bonds to a carbon. That's a Texas carbon. No Texas carbons. How could we also figure that out? Well, are there any hydrogens on this carbon? No, that carbon is bonded to 4 other carbons. So it cannot undergo this type of reaction because it needs a hydrogen to do that. So for both of those reasons, this one would only have a single product that we see there. Okay, what about this next one? This next one has the 2 hydrogens on this spot. Both of them could be deprotonated, and that would form a trans or a cis. There are no hydrogens on that carbon again, just like what we talked about up there. So we can only pull off those 2 protons. That would result in a trans version. And this cis version, again, is going to be pretty disfavored. This would be the major product, and that would be heavily a minor product here. What about this one? Again, we have a hydrogen here in this beta position, a hydrogen here in this beta position. We'll call this H1, H2. If we deprotonate H1, we would form the alkene right here. So this is H1. If we pull up H2, we would form the alkene right there. Are either of those major or minor? They're both di-substituted, so they're both of similar stability, so they're both going to be roughly equal parts. So those would both be major products here. Last one, we can pull the hydrogens off of this position. And this position is actually identical to that position, right? It's a symmetrical molecule. So essentially, we are going to form a mixture of that and the cis version. So this would be the major product. This one would be a minor product. Even though they're both di-substituted, cis is less stable than trans. So hopefully that predicting the product went pretty well. And now we're going to move on to, I would say, what is the most challenging component of this chapter. It's and of this unit in general. It's the stereochemistry mixed with this E2 elimination chemistry. So being able to find the right proton that makes. So what I said earlier is one of these protons is going to make that one. The other proton makes that one. So how do we figure that out? How do we know which one is making what? And that's where we're going next. So it's the most fun part too. So hopefully you guys agree.